Safe and reliable weight handling is critical to the operation of the Navy. Each day, the Navy uses its inventory of weight handling equipment to service ships, submarines, aircraft, and shore facilities to support the Navy's worldwide commitment. These weight handling operations take place at hundreds of naval activities, involving thousands of cranes, thousands of personnel, and tons of rigging gear. Safe performance during these operations is key to eliminating damage to equipment or personnel injury. Mobile cranes make up approximately 8% of the Navy's crane inventory, yet they account for almost 40% of all crane accidents. More than half of these accidents have occurred without a load on the hook, and mobile cranes are involved in some of the most serious accidents. The Navy Crane Center reviewed mobile crane accidents occurring at Navy shore activities between 1998 and 2003. During that period, there were 433 mobile crane accidents, including 83 collisions, 38 dropped loads, 44 tube blockings, 38 overloads, and 22 personal injuries. The results of the study show that 93% of mobile crane accidents are caused by personnel error, including improper operation, improper rigging, and failure to follow established procedures. Clearly, the everyday decisions made by members of the crane team will have a significant impact on making every lift safely. Mobile crane operation is one area where better decision-making could produce a high rate of return. This video focuses on 7 key elements that will increase mobile crane safety awareness for crane teams. Laying a foundation for safety. Teamwork. Mobile crane setup, understanding crane capacities, rigging considerations, safe operating procedures, and traveling and securing mobile cranes. Laying a foundation for mobile crane safety begins with meeting the requirements of NAVFAC P307. All personnel involved in the crane operation must be properly trained and qualified to do their jobs. Mobile crane operators must be licensed to operate the types of cranes to which they are to be assigned. Some mobile crane accidents have been attributed to operators engaging the wrong controller. This may be due to a lack of familiarity with specific cranes. Supervisors must ensure that operators are familiar with specific makes and models before assigning them to a crane. Operators must also read and thoroughly understand the crane operator's manual, including the load chart. Riggers who work with cranes must also be trained and qualified. Supervisors overseeing crane operations must be aware of the requirements for safe lifting operations. They are strongly encouraged to attend the appropriate Navy Crane Center training to become more knowledgeable about cranes and rigging. Selecting the right crane for the job helps form a solid foundation for safety. Using the right crane ensures that an additional risk is not introduced. The supervisor should visit the site and determine the proper crane for the job. The proper crane should be able to lift and set the load without exceeding 80% of the crane's capacity at the required radius whenever possible. Activities must also identify complex lifts and develop procedures for conducting them. Complex lifts include hazardous materials, large and complex geometric shapes, lifts of personnel, lifts over 80% of the crane's capacity, 50% for cranes mounted on barges, lifts of submerged or partially submerged objects, multiple crane or hook lifts, and any other high-risk operation. The rigger in charge must be able to recognize complex lifts and follow the complex lift requirements. Activities should use the principles of operational risk management or ORM, to assess and manage the risks involved with mobile crane operations. The ORM process is a logic-based, common-sense approach to making calculated decisions to mitigate risks and hazards associated with crane and rigging operations. First, identify the hazards. Then, assess each hazard in terms of its probability of occurring and the severity or consequences should it occur. Based on this assessment, make the risk decisions and implement the controls needed to perform safely. Finally, monitor the operation for any changes that might present new hazards. For most routine lifts, the process is an on-the-run mental or oral review of the situation and implementing the necessary controls. For complex lifts, the process will be more deliberate and formal. If an accident occurs, stop operations. Place the load in a safe condition. Secure the crane. And contact your supervisor immediately. Remain at the worksite and preserve the accident scene so a thorough investigation can be done to ensure lessons learned can be communicated and applied to prevent future accidents. All crane accidents and near misses must be reported to the Navy Crane Center as required by NAVFAC P307. Teamwork is a key element for mobile crane safety. When the crane team works together toward a common goal, such as making each lift safely, the likelihood of success is greatly increased. Crane teams must follow NAVFAC P307 and local procedures developed to ensure safe operations. Following established procedures could have prevented nearly 1/4 of all mobile crane accidents reviewed in the Navy Crane Center study. Supervisors should consider the job when determining the crane team size. Some lifts may require only a rigger and an operator. Others may require additional personnel to rig and control large or bulky loads. The rigger in charge is given the responsibility for the overall safety of the lift. However, each member provides expertise that should be used in the decision-making process. Each team member is responsible for safety. Careful lift planning is essential to making safe mobile crane lifts. A supervisor or a working leader shall conduct a separate pre-lift brief for all complex lifts. Team members should pay close attention to their assigned jobs during the entire lifting operation. However, they should always keep the big picture in view. When several eyes are watching a lift from different perspectives, chances are greater that a problem will be identified before it becomes an accident. Continuous good communication is essential. All crane team members must be able to provide feedback or get clarification before, during, and after the lift. Remember, anyone can stop a crane lift when there is a safety concern. When challenged with problems that you cannot resolve by yourself, first, try to work it out with your team members. If that doesn't work, ask your supervisor to help resolve the issue. When changes to a lift plan are made, all team members affected need to know what the changes are. Even small changes may impact the safety of the lift. When changes occur during a lift in progress, the rigger in charge should stop the lift, communicate the necessary changes, and then continue with the lift. Communication must continue during every crane lift. Almost 10% of all mobile crane accidents studied were caused by poor communication. Team members must also inform the rigger in charge of any safety concerns during a lift. Team members must stay in a safe position at all times during crane operations. Avoid walking under loads or booms, or even beneath empty hooks, and stay out of potential pinch points. Each team member should adopt a personal goal of 0 accidents. To do this, they must fight complacency, follow established procedures, pay attention to detail, and use personal protective equipment in crane working areas. Proper crane setup is required for safe operations. Before moving the crane to the worksite, operators must do the necessary operator daily checks. Operators must also check the remainder of the pre-use items at the worksite. The supervisor should plan the route to and from the worksite to ensure that load-restricted areas are not used for crane travel. Ideally, the crane worksite should provide adequate room for crane setup and maneuvering. The work area should be free from obstacles, including vehicle or pedestrian traffic. Mobile cranes should be set up so that no part of the crane or load can come within the prescribed clearance distance of overhead electric power lines. When necessary to work around obstacles or hazards, be sure the entire crane team is aware of them. The crane rigger should assist in positioning the crane by watching clearances and giving the operator directions as needed. When maneuvering truck cranes, make sure the rotate lock is engaged. The rotate brake alone is not enough to prevent crane rotation while traveling. The result of unexpected rotation can be an overturned crane. The worksite must provide adequate ground support for the outrigger pads, which create extreme ground pressures during heavy lifts. Ground conditions may require the use of cribbing or pads to spread out the ground loading. Saturated soil or ground that is either freezing or thawing may require additional supporting materials. Operators must read and follow all posted cautions and any operational restrictions. Follow the manufacturer's setup requirements for each lifting configuration. Extend outriggers as required. When using variable position outriggers, extend as necessary and use the correct load chart for determining crane capacity. When extending multi-position outriggers, ensure that the beams are deployed only in accordance with the manufacturer's instructions. Outrigger beams typically have extra support in the load-bearing areas to prevent collapse under load. Level the crane within 1 degree, or as required by the crane manufacturer, and ensure all tires are kept close to, yet clear of, the ground. Ensure outrigger pads are attached or pinned to the jacks as required by the manufacturer. This will prevent detachment of the outrigger jack should the jack rise up when the load is over the opposite corner. Make sure outrigger pads are not placed over underground utility tunnels or drainage pipes. Areas over tunnels or pipes often will not provide adequate ground support. Optional counterweights may be required to achieve higher capacities on cranes having this option. Front bumper counterweights are designed to help increase capacity only when lifting over the rear. Position counterweights as required by the manufacturer for lifting. Caution should be used when doing operational checks in freezing weather. Operators should always hoist up first before lowering. Operating the hoist down with frozen sheaves may unspool wire rope at the drum. Operators should not use high-speed lowering with empty hooks. This can result in fouled wire rope at the hoist drum. Before lifting a load in wet weather, brakes and clutches on friction cranes should be operated until dry to prevent slippage. No-load operational checks include testing limit switch operation. Extreme caution must be used to prevent two-blocking when checking the bypass function during operator checks. In the past, two-block accidents have resulted in fatalities at Navy activities. Everyone must remain alert to the possibility of two-blocking. When installed, load moment indicators, or LMIs, must be checked to ensure they are operational. Accuracy can be checked by putting the boom at a known angle, measuring the radius, and lifting a known weight. These known values are then compared to those shown on the display. In the period from 1998 to 2003, 25 accidents occurred while erecting or stowing ancillary equipment. When erecting or stowing ancillary equipment, such as swing-away extensions, follow the Navy Crane Center approved procedures developed by your activity. Follow the manufacturer's guidelines for travel with jibs or extensions erected if allowed. Rope off or barricade crane work areas to keep unauthorized personnel or vehicles out. Observe local operating restrictions such as pier loading. 33 accidents from 1998 to 2003 were attributed to mobile crane overloads. Understanding crane capacity is critical to the safe operation of a mobile crane. Crane operators must be able to determine crane capacity using the manufacturer's load chart information for all lifting configurations. The load chart includes requirements for proper setup and deductions from gross lifting capacities. Also included are capacity limiting factors such as line pull and requirements for use of optional hook blocks. The range diagram is a valuable planning tool used to determine whether a lift can be made with a specific crane or configuration. On most mobile cranes, deductions from gross lifting capacities must be taken for components attached to the boom, such as the main block, the auxiliary block, stowed or erected extensions, and auxiliary boom heads. Always consult the manufacturer's load chart for applicable deductions. LMIs provide valuable information to the operator, but must be used only as an operational aid. They must never be used to replace the load chart. A mobile crane's capacity can be limited by parts of line or hook block capacity. Be sure you know the certified capacity, which is posted on the crane. Mobile cranes mounted on barges must meet the requirements of NAVFAC P307. Load chart capacities may need to be reduced to account for the hazards of lifting on water. The crane must be tested and certified for use on the barge. Cranes with outriggers must be secured to the barge with slack tie-downs. Crawler cranes mounted on barges must be tied or tethered to the barge. All cranes operating from barges must be equipped with list trim indicators. Lifts exceeding 50% of the capacity of the crane or hoist must be treated as a complex lift. Special operating considerations for barge-mounted mobile cranes include assessing the effects of wind and rough waters, ice formation on the barge deck, and waterway traffic. Improper rigging is the third leading cause of mobile crane accidents. Knowing and verifying the load weight is necessary to select the right gear for the lift. Selecting the right gear for the job is just as important as selecting the right crane. Be sure to add the weight of the rigging gear to the load so that the total load to be lifted is known. Keep the operator informed of the total weight of the load to be lifted. Select the proper rigging gear for the job. Rigging gear is sized based on the weight of the load and the sling angles. You must consider the increased forces that are induced whenever slings are used at any angle other than vertical. Remember that the distance between the attachment points and the length of the slings used affects sling angles. In addition, when eye bolts are used, eye bolt capacities must be reduced for angular loading. Unless special equalization methods are used in 4-point picks, size the slings based on the worst-case distribution of loads. Slings should be sized so that 2 legs will carry the weight of the load. Protect slings from sharp edges on the load to be lifted by using chafing gear. Evaluate lifting attachment points for damage and correct positioning. Inspect pad eyes for structural integrity. Ensure loads are balanced by determining the center of gravity before rigging the load. When the load is balanced with the hook directly over the center of gravity, the load will lift evenly. With the load lifted just high enough to clear the ground, double check for balance and proper operation of the hoist brake. Control loads by using tag lines when appropriate with as many line handlers as needed to control swing and rotation of the load. When giving directions to the crane operator, make sure they are clear. During complex lifts and blind lifts, communication must be continuous. When directing the load from one location to another, such as from the pier to the ship, the signaling responsibility transfers to the receiving rigger. This transition must be clearly communicated to the operator. Following established crane operating procedures helps to ensure the safety of mobile crane lifts. Operators and riggers must consider the effects of wind, temperature, and visibility before making lifts. When operating near overhead power lines, the line should be de-energized and visibly grounded whenever possible. When power lines cannot be de-energized, a minimum clearance of 10 feet is required for lines up to 50,000 volts. For higher voltages, consult NAVFAC P307. When any part of the crane or load has the possibility of moving into the clearance zone, a designated observer shall be used to ensure clearances are maintained. When determining the minimum clearance distance, consider the possibility of the wind blowing the wires or boom deflection bringing the crane into the danger zone. Bypassing safety devices such as limit switches during lifts is prohibited. Two-block accidents have occurred while the operator is concentrating on the loaded hook block while ignoring the location of the unloaded block. When the unloaded hook is a whip hook with a single part of line, the results can be catastrophic. Operators must be aware of the position of the crane hooks at all times to prevent two-blocking. For cranes without limit switches, use other methods, such as marking the wire rope or using a spotter to warn when hooks are close to the boom tip. Crane operators must stay in complete control of loads at all times, controlling hoisting and rotate speeds. Many load collisions are the result of moving loads too fast or not having the hook centered over the load prior to lifting. Improper operations have resulted in wire rope coming off the sheaves on mobile cranes. To prevent this from happening, avoid swinging rapidly while hoisting. Always keep the boom tip over the load to prevent side loads. When lifting heavy loads with long booms, operators and riggers must be aware that boom deflection will affect the radius of the load. Operators should compensate by booming up prior to lifting the load to maintain load radius. This operation may require the simultaneous operation of the hoist and boom. Power lowering should be used for all loads, except for very light loads on cranes that have free-fall capability. When landing heavy loads at minimum radius with lattice boom cranes, boom down to place the load on the ground, using care not to exceed the maximum radius for the load. This prevents the boom from recoiling into boom stops and causing possible damage. Free-rated lifts, including on-rubber lifts and pick-and-carry lifts, may be done only when allowed by the manufacturer and when the crane has been certified for on-rubber lifts. Special precautions required by specific crane manufacturers may include keeping the boom as short as possible, keeping the load low to the ground and close to the crane, and using taglines to control loads as needed. As an additional safety measure, outriggers should be extended and clear of the ground for traveling. When finished with the crane, prepare it for transport. Hooks must be prepared for travel by securing with tiebacks having a braking strength less than the hoist's capacity as reeved. Follow local procedures for specific instructions. Removable or extendable counterweights must be secured for traveling. Serious damage can occur when cranes are traveled with counterweights in the operating position. Travel the crane only over a pre-planned route. If necessary to travel under power lines, the minimum clearance for cranes in transit is 4 feet or greater, depending on the voltage, as required by ASME B30.5. Secure the crane following the manufacturer's and local procedures. Take a moment and enjoy the feeling of having an accident-free day. Shore-based activities rely on many types of mobile cranes every day to service ships, submarines, aircraft, and facilities. The safe and reliable use of cranes directly and significantly contributes to fleet readiness. The crane teams and managers overseeing mobile crane operations have a responsibility to work together to ensure Navy cranes are able to meet the daily demand to safely support the Navy mission. Mobile crane accident prevention is a key factor in meeting this demand. 93% of mobile crane accidents are caused by personnel error. Everyone must maintain a personal goal of 0 accidents. Each member of the crane team should strive to develop an attitude of safety that says, I am going to do my part to make every lift a safe lift. The Navy Crane Center is a ready resource available to help you with crane accident prevention and your weight handling program needs. Error, including improper operation, improper rigging, and failure to follow established procedures. Clearly, the everyday decisions made by members of the crane team will have a significant impact on making every lift safely. Mobile crane operation is one area where better decision-making could produce a high rate of return. This video focuses on 7 key elements that will increase mobile crane safety awareness for crane teams. Laying a foundation for safety. Teamwork. Mobile crane setup. Understanding crane capacities. Rigging considerations. Safe and reliable weight handling is critical to the operation of the Navy. Each day, the Navy uses its inventory of weight handling equipment to service ships, submarines, aircraft, and shore facilities to support the Navy's worldwide commitment. These weight handling operations take place at hundreds of naval activities, involving thousands of cranes, thousands of personnel, and tons of rigging gear. safe operating procedures, and traveling and securing mobile cranes. Laying a foundation for mobile crane safety begins with meeting the requirements of NAVFAC P307. All personnel involved in the crane operation must be properly trained and qualified to do their jobs. Mobile crane operators must be licensed to operate the types of cranes to which they are to be assigned. Some mobile crane accidents have been attributed to operators engaging the wrong controller. This may be due to a lack of familiarity. Safe performance during these operations is key to eliminating damage to equipment or personnel injury. Mobile cranes make up approximately 8% of the Navy's crane inventory, yet they account for almost 40% of all crane accidents. More than half of these accidents have occurred without a load on the hook, and mobile cranes are involved in some of the most serious accidents. The Navy Crane Center reviewed mobile crane accidents occurring at Navy shore activities between 1998 and 2003. During that period, there were 433 mobile crane accidents, including 83 collisions, 38 dropped loads, 44 tube blockings, 38 overloads, and 22 personal injuries. The results of the study show that 93% of mobile crane accidents are caused by personnel errors.